Okay, so the final, it'll be worth about 150 points, so it's a little bit more than a regular test. There are some things about it. You can only do one retake on it. Okay? So I want to really emphasize how important it is to check everything, right? You got to check everything. But the good news is, it's not very hard. There's no question this is not as hard as my normal test are. I don't think it's even close to as hard as my normal tests are. So that's good. All right, so write the equation, or write the quadratic expression in factored form. I mean, this is, this is about the easiest question I could possibly give you. What do you do to factor that? Yeah. What are the magic numbers here?
Negative 10.
Negative 10, positive 6. Multiply to negative 60, add to positive 4, right? Thank you. And that's the answer. Okay, so real quick, how could we check this? Anytime they ask you to solve something, it's a no-brainer. You just, whatever your answers are, you plug the solutions back into the original equation and see if they make it true, right? If it's not something like that, if it's something where you're trying to write something in a different form, or it tells you to simplify something, then remember the trick is, you could pick a random value of x, and if I plug the random value of x in up there and down there, I should get back the same value, right? If I don't, then either I just calculated the numbers wrong or I did the algebra wrong. I gotta take a second look at it. Yes, sir.
How is it negative 10? Isn't it positive 10?
Oh, it is. You're right. We got that backwards, didn't we? I didn't really look. I was just listening there. Right, and you got to be real careful with those signs. That's a common mistake. So we get x. We need a positive 10 and a negative 6, don't we? Yeah. Okay. So I'll skip that. That's the same thing, right? Just got to find magic numbers. No big deal. How about this one? Write this one in factored form. Okay. So there's a couple things we could do. Now, in this case, we always want to try every time, no matter what we're doing when we factor, we always want to try to factor out a GCF. The last two, we couldn't do that, obviously. But on this one, we want to try. Doesn't work, though, right? There's nothing I can undistribute from all the terms. So in that case, if we end up with a is not equal to 1 like that, right? If a is not equal to 1 and we're trying to factor something, then that means we've got two choices. One is bottoms up. And two is we can just reverse the quadratic formula. Bottoms up, I think, is a little bit easier, but we'll look at both of them. Okay, so what about bottoms up? So bottoms up, remember, to do bottoms up, we have to find our magic numbers. They're a little bit harder to find for bottoms up, though. Right? We have to find magic numbers that multiply to a times c. What is the product of a and c? Well, a is 8, c is 21, right? 8 times 21 is 168. And they have to add to b, which is equal to 34, right? So we just got to go find those numbers. What are the signs going to be of both? Positive, right? So we'll just try to find stuff. We could do 1 times 168, but that's not going to work because the sum is way too big. We could do 2 times what? 84, no good. We could do 3 times 58, no good. We could do 4 times 42, no good. If we keep going, eventually we'll get to 5 doesn't go into it, but 6 does. 6 times 28, and that's the winner, isn't it? Right? If we just find all those factors of 168, eventually we're going to get to one that does the job, right? That adds to b. Okay, so we found it. We got our magic numbers. That's step 1 for bottoms up. Okay, step 2. Remember, step 2, we're going to start off, it's going to look just like that, right? We're going to start off with our regular factoring template. So for bottoms up, Step 2 would be, we would just start with something like that. And we're gonna take our magic numbers. Just like we normally would. Obviously that doesn't work, right? If I were to multiply that out, I'm gonna get an x squared instead of an 8x squared, and I'm gonna get a huge number instead of 21. So it's not right, but it's the first step. What's the second step?
Divide by 8.
Yeah, good. We have to take whatever's out front, and we have to divide both of our magic numbers, that's step 3, by that, right?
Wait, I thought you said that the green was the first step, not the second step.
It is, right. The first step was just to find out what those numbers are, right? And then the second step was to write the template. Third step is to divide, once we get the template written, we're gonna divide the magic numbers by A, whatever that is. And then finally, last step is just to simplify and go bottoms up if we need to. Okay, so what is this one, what does that fraction reduce to?
X plus 3/4.
3/4, good, so we get x plus 3/4. And what does this one reduce to?
Would be 1. Wait, 1/4. Wait, no, 4 on top. and then
6.
7 on
Then over 2.
7/2. Okay, and remember, if we end up with fractions in the bottom, when we simplify the fractions, then we have to go bottoms up, right? And so, I guess this is sort of the last step, or just the last part of the, I don't know how you want to describe how many steps it is, but this is the last thing we got to do then, right? We've got to take that 4 and go bottoms up, and take the 2 and go bottoms up. If there were no denominator, we wouldn't do it. So our final answer then is just going to be 4x plus 3 times what? 2x plus 7, right? Okay, how would we check that? Honest. Jeez, watch this. So, how do we check it?
No, no, no.
We could plug in a number. Yeah, we could. We could also just multiply it out and see if we get that, right? Factoring is just unmultiplying, right? If we multiply it out, we'll just undo all that work. It should get us right back where we started, okay? All right, so that's one way to get there. How about reversing the quadratic formula? Well, we can do that too. So if we reverse the quadratic formula, what are the values of A, B, and C? So I guess what I'm gonna do, let me write this down. So that gives us 8x squared plus 34x plus 21 equals 0. Now the reason we're going to do this, if we reverse the quadratic formula, we're going to get the zeros of that expression, right? Remember that the zeros and the factors always go together, right? If I have, for example, let's just say that I had the 0 for some problem, let's say I had the 0 x equals 2. What's the factor that goes with that? X minus 2, right? All I've got to do is just set that equal to 0 by subtracting 2, or think backwards and ask yourself, okay, what would I set equal to 0 to get an answer of 2? It's always x minus the 0 is how you create the factor, right? So let's just do the quadratic formula then, get the answers from the quadratic formula, get the zeros, and then just reverse those to get the factors, right? Subtracting from x and reverse them. So what's the quadratic formula give us? Well, we know negative b plus or minus the square root of b squared minus 4 times a times c, right? All divided by 16, there we go, okay. So let's see, what do we get then? 34 squared, yikes, what is that? Somebody find that out for me, what is that, real quick?
34
Yeah, 1 10 like 5 6 or something. What is that?
Negative 34, and another.
Well, because I mean it's just quadratic formula. X equals negative b. Right?
1156.
What is it?
1156.
56.
Oh, I thought 105. Okay. I was way off. 1056 minus 4 times 8 times 20. That's 168 times 4. So
It's 11356.
what is it?
1
Oh, that's right. 1156. Guess I should go with the right answer instead of mine. Minus 168 times 4, so that's going to give you 320, 640 plus 32, so 676. All divided by 16, and that's plus or minus, right? So what's that give us in here? What is that? 480? Is that right?
I got 672.
Oh, 672, you're right. So it'll be 484, which is 22 squared. That's right. Okay. Okay, so then we end up with x equals negative 34 plus or minus. All that's just going to become, if I put that into a calculator, I just get plus or minus 22 all divided by 16. Okay, so then look what happens. If we take the plus sign, look what we get. We're just going to get x equals negative 34 plus 22. What is that? Negative 12
Yeah.
divided by 16. Well, what is that? Negative 3/4? Everybody agree? Okay, so if I turn that into, let's turn that into a factor. So then that would just give me x minus negative 3/4, x plus 3/4. Does that look familiar? It's minus a negative, right? We always subtract the 0 from x. So x minus negative 3/4 would be x plus 3/4. That looks familiar, right? There it is. Right there, right? Okay, so that would put us there. What about the other factor? If we take the minus, we'd get x equals negative 34 minus 22 is negative 56 over 16. So what is that? That's going to be, there's our 7/2, isn't it? Equals negative 7/2. So that gives us the factor x minus negative, so positive 7/2. Once again, there it is, right? And so now I'm to this point, what's the last step? Bottoms up, okay, to get the answer. So you actually can always work backwards with the quadratic formula too. I think bottoms up is a little bit easier personally, but the quadratic formula, it works to do that. Okay,
What will
yeah.
be the answer of it?
So it's this. That's the answer. Okay. And that's what we get here too. I mean, if we took the product of those two, we just had to go bottoms up and move the 4 up and the 2 up. You know, that's what we get.
I think bottoms up.
I think it is. I think it's a little easier. Okay, so what about this? Completely factor the polynomial. Okay, this is, I mean, what do we do with two terms? Like this?
Factoring pattern.
Factoring pattern, right.
It's 11.
We can't take anything out, so we gotta use a factoring pattern. Which one is this?
The difference is
Difference.
Good. A squared minus b squared, what's that equal?
11.
Well, this, yeah, but I mean, what's it in general? A squared minus b squared is?
A plus B plus A minus B.
Good. So then we have x squared, x instead of a, and instead of b, we have 11, right? Because 121 is just 11 squared. And so what's that equal to? Well, x plus a times x minus a. There it is.
That's your answer?
Yeah, that's it. That's factored, right?
So it's not 11? It's plus 11.
Yeah, it's x plus 11, x minus 11. When we're factoring it, we're not solving it. You were solving it. would have been plus or minus 11, right? But we're not solving it, we're just factoring. Okay? All right, how about this? Solve the equation. Well, it's already, they did all the hard work for you. It's already factored, right? So what do you do when you take an equation? This is the strategy. We've probably done this about 1,000 times this year, conservatively. All we do is we factor, put the equation in factor, or in standard form, set it equal to 0, factor it, and apply the zero product property, right? Set the factors equal to 0. So that's all we have to do here. What's the 0 of that factor?
6.
Well, 6
7.
divided by 7, right? If I actually, and I can do that, I can just set it equal to 0 and solve if I want to. I'd add 6 to the other side and divide by 7 and get 6 sevenths, right? How about this one? If I set that equal to 0 and solve, I gotta add the 9 to the other side and then divide by 4, right? So those are my two solutions. Okay? We good?
That's all I have to do?
That's it, right?
So you put like 6 7 comma and 9 plus.
Yep, yeah, you're gonna separate them with commas. Yep.
Didn't you say that there's like 10 questions on
Say it again.
that? Did you say like there's only gonna be like 10 questions on the final?
No, there's 28 on the final. Yeah. Yeah, this
And you
is,
can- And you can access them all, they're not like.
yeah, they're not, you can go out of order if you want to. Yeah. This is, people ask, I mean, it's a big enough test, I'll let you do it. This is Blue Mountains, just their exit test for Math 95. That's what it is. Okay. So, how about this? Solve the equation. Well, what would we do? I mean, what are your options? You have options. Magic numbers, quadratic formula, right? All you're doing is solving a quadratic formula in standard form. Either you factor and set the factors equal to 0, or quadratic formula. Which is easier? Magic numbers. So what are they?
-10.
And good. So what do we get for answers?
10. 10 and 8.
Right? Okay. Okay, how about this? Solve the equation. Now here, I'll tell you something about. I'm gonna go back. Okay. While people are writing this down, I'll tell you something about this. I didn't change on Blue Mountains test. The question like this would say, find real solutions. So all this stuff up here about if your solutions have imaginary parts, blah, 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 they won't. The answer is there will be no I's in any of your solutions, right? They're all just gonna be real answers. So you won't, if you get an I, you did it wrong.
There will be any imaginary.
No imaginary numbers. No, this is a pretty, on the whole test.
Yes. Can you use a calculator?
You may not use a graphing calculator. I think it's their rule. I think you can use a regular calculator.
Like the one on the computer.
Like the one on the computer, yeah.
Can I use this?
Okay, what about this? Here we go.
Factor pack.
So you could do a factoring pattern on this, x minus 3, x plus 3, which gives you back, if I set them equal to 0, I'd get -3 and +3, right?
So what,
Or something.
okay, so it says it's A plus BI. That, we just ignore that?
That's what I'm saying, ignore that. Ignore all that stuff. That's, I mean, we did a lot of that stuff during the year, but we're not, they don't have it on their final, so I won't put it on our final, okay?
Yeah.
All right, so we could use a factoring pattern, but remember, if we're just trying to find the real solutions, remember our rule, if I can point to a single x, I can isolate it by reversing order of operations, right? So how would I isolate x there? What do I do first?
Add a 9.
Then what? Take a square root and I get x equals plus or minus 3. So in Moodle, I would just go 3, -3, right? Okay. Solve the equation. Okay, it's super easy, right? When they have two terms like this, it's pretty simple, right? You don't have to do much. You don't even have to find magic numbers. Either you're going to use a factoring pattern if it fits, but it doesn't fit here, right? That's not a difference of squares or a sum or difference of cubes. I'm only going to give you difference of squares on the test too. It's only when you really have to know for this test. I mean, the rest of them you've done all year. So what do we do with this one though? What do we always try to do with any polynomial to make it easier? Undistribute. What can we undistribute here?
X.
X, good. So we'd end up with x times what? X plus 7 equals 0. So what are the zeros? What's the value of x that makes that factor 0? 0. Anytime you have a monomial factor with a variable in it, it's 0, right? And then this one, that's it. Okay. How would I check those? Plug them in.
Wait,
Okay,
so
I'm-
you put 0 and then comma -7.
Yeah, that's what you do, exactly. Yeah, you're gonna put them with a comma. Okay, so what about this? Same kind of thing we did earlier, right? If we're looking for real solutions, just isolate,
Divided by -2.
right? So then that gives me x squared equals 81, so what's x?
Square root of 9.
Plus or minus.
Oh, well, I meant square root of 81.
So in Moodle, like that.
Hold on.
Okay, so,
Wait, why is that supposed to?
say it again. Okay. Whenever I square root, I take an even root of both sides, but on this test it'll only be square roots. Gotta get a plus or minus in there, right? Okay, continuing on. How about this? Very simple stuff, right? Very simple stuff. This is the one where there's actually two questions. I'm just gonna do both of them at the same time. There's two questions. There's another one. Oh no, okay, it's not even on this version. But there will be two questions on the test that'll show up about this. It's going to ask you to determine what C is, and then I'm also going to ask you write the perfect square trinomial that you create in factored form, right? So this is the stuff we did way back when we completed the square. They don't even have you complete the square. They just want you to know how to create a perfect square trinomial, right? So what would that be? Remember how we did this. If we have x squared minus 28x, remember we put a box there, and then we created our perfect square, right? And then these were all related. What did we do? How did we always do that? What's the number that goes with x in factored form when it's a perfect square? No, what is it?
Don't we divide it?
Yeah, we do. We divide it by 2. Yeah, so it's just minus 14, right? And then whatever that is, so this is the value of C. What's it going to be? Negative 14 squared. So it's 196, right? So to get here, this is always going to be, the number that goes in here is always going to be
Half of 28 squared.
half of 28 squared, right? Half of whatever that number is, squared. So C is always going to be positive, isn't it? Because when you square a number, it's always positive,
Yeah.
right? And then the other thing they'd want you to put in there, in the other question, is just this. Okay, if you write the perfect square trinomial, which is this is a trinomial. Three means try. It's got 3 terms. A trinomial that factors into something squared, right? So that's going to be the other question you'd be asked to do. Okay? Okay, how about this? Solve the equation. We already did one like this. What would we do? Quadratic formula. I mean, we could try to factor it, but I would recommend if you're solving it, if they're not asking you to factor it, they just want you to solve it. Quadratic formula. We can't factor anything out. There's no greatest common factor that we could factor out and divide both sides by. No number, right? And so, yeah, that's definitely a quadratic formula problem.
So if it says solve the equation, you do the quadratic.
If this number in front of x squared is not 1, yeah, then you definitely want to. You don't want to try to, because to factor it, you'd have to do bottoms up, and it may not even factor,
Wait,
right?
so if it has a different number than 1,
Yep.
then you don't do.
Then you do. If it's got 1, we'll just do it like we did, like with, where's one that we did? Right there, right? If I solve that, I'm just going to find magic numbers, right? Factor it and set the factors equal to 0, because it's easy to factor. But if it's one like this, well, that's hard to factor. So we would just plug A, B, and C into the quadratic formula and carefully simplify that, right? Okay? I'm not going to do that one, though, because we already did one like that. We did one, where was it? It was back there a ways. Right down here, right? It was. We already did a quadratic formula problem down there, and we got our solutions, right? Okay. Okay, so what about this? This one's got a 1 in front of the x squared. So we're going to try to factor it, but are there magic numbers that multiply to 7 and add to 10?
No.
There are not, right? So this is another one where we have to use the quadratic formula. But this time, because it didn't factor, we might end up getting square roots in our answer, right? So if we plug this in, we know A is what? 1. What's B? What's C? So then we know the quadratic formula. You got to know it, but that's the song. Everybody knows the song.
Yeah.
So x equals, okay, get your singing books now. What's the song?
That's the wrong song.
No, that's not it.
Negative b.
X equals, come on now.
Negative b plus or minus square root b squared minus 4ac divided by 2a.
There you go, beautiful. Okay, so we'll just plug everything into that, right? We'll plug all our values in and simplify. So what do we get? So we get x equals negative b is negative 10.
Plus or minus.
I'm going to wait a second here. Okay, positive 10 squared. Right? Okay. Minus 4 times 1 times 7, right? Okay, I need you guys over here. You guys turn around, face front, plug in here, please. Thank you. All right, so then on the bottom we get 2 times 1 is just 2, right? So we can simplify this. This won't be hard to simplify. We get negative 10 plus or minus the square root of 100 minus 28. What is that? You heard it, I think. 72. All divided by 2. So then really the hardest part of this is just simplifying a radical. That's no big deal. Simplifying a square root. So let's take the square root of 72 and let's break that in. Let's see if we can minimize the radicand. Right? We want to get as much out of the radical as we can. In other words, what's the biggest perfect square factor of 72? 9 goes into it. You could get a bigger one though. 18 is not a perfect square. Not a perfect square. Perfect square means a number squared.
12.
So think what we got. 4. Yeah, that would work, but we can do better.
6.
6 is not a perfect square. Oh, you mean 6 squared. Yeah, right. 36. That's it. If we go down the list, right, maybe hopefully that's it. So we got 2 squared is 4, 3 squared is 9, that would work. 4 squared is 16, wouldn't work. 5 squared is 25, no good. 6 squared is 20, it's 36. Bingo. 36 goes into 72 twice, right? So we could write this as the square root of 36 times 2. We'll just split that into separate square roots. Then we put a circle around that one. How come?
Because it's a square.
Because it becomes a 6, right? It's a perfect square. So then what's our answer look like? So going back to our problem then, we end up with negative 10 plus or minus 6 radical 2. Now let's do something else here. Instead of putting this all over a common denominator, let's go ahead and split these up so we can simplify each one. Right? Remember how we always did that? What does this become?
Negative 5.
What happens here?
6 and 2,
You
so
got
you
it.
get,
Okay, so I get 3 over 1, right?
you get 3 radical 2.
Good. So in Moodle, what would our answer look like then?
So 3 round 2.
Comma, negative 5 minus 3 radical 2, right? Okay? Right? How could we check this with a calculator?
Put it in.
Yeah, I mean, one way you could do this is you could just turn this into a decimal, right? Put the decimal into your original problem up here, and it should give you 0. Now, it may not give you exactly 0 because it's a decimal, but what if it gave you an answer of like 0.1 or something, Well, yeah, it's trying to give you 0, right?
It's not good enough though.
Okay, how about this? This ought to look pretty familiar, right? This is the stuff we're doing now. So what do we, anytime we want to simplify a rational expression, so you got a big fraction involving exponents, put our phones away, please. Or we're adding or subtracting rational expressions, or we're multiplying or dividing, or any of that stuff, solving a rational equation, we always want to start by factoring everything, right? So then on this one, top's already factored. What does the bottom factor into? Okay, magic numbers are +7, +8. So what happens? How do we simplify it?
The bottom side.
Because we want to find magic numbers that multiply to 56 and add to 15. Right, so we're going to split that bottom, that denominator.
So you find the common denominator between 15 and 66?
We want to find, we just want to, we're just finding magic numbers, right? We're just trying to factor that trinomial, right? Break it apart into a product of two factors.
Take away the x plus 7.
So we can cancel the x plus 7, right? Okay? So then what's that leave on the top?
1.
1, yeah. So we end up with 1 over x plus 8, right? That's our answer. How do we check it? Plug a number in, see if you get the same thing, top and bottom, right? Okay. How about?
How would you plug a number in? You just go.
Okay, yeah. Well, let's just do that. What if I pick? Let's just pick 1. If I pick 1, and I plug 1 in up here, what's this going to give me? So I'm going to x equals 1. This is going to give me 8 over 1 plus 15 is 16, plus 56 is 72. What does 8 over 72 reduce to? 1/9. Okay, if I plug in x equals 1 here, what does it give me? Those are equal, right? So it worked. Find the product. Okay, same as before, right? Products are easy. It's the adding and subtracting gets a little harder. We want to find all the common factors. We want to find the factors first of all, and then we'll cancel any common factors to simplify, right? So we're going to factor. Top's already factored. Bottom factors into what?
6 and 5.
So what are the signs going to be?
-5, 6.
There you go. Okay, so we need them to add to a positive, so the bigger one is the positive one, right? And then this guy's already factored. Remember, when we multiply straight across those. So we don't even really have to put that time sign there. We could just kind of include those factors of the top. The x minus 5 goes there. And the x plus 5 goes there, because I'm just multiplying straight
So the x
across.
minus 5 cross out.
So it will, right. Okay, so then those go away. Now remember, on my test, well, actually you guys aren't taking this test, are you? So you lucked out. So what would the restricted values in the domain be? What are the values we'd have to exclude? Just real quick, make sure you know this. -5,
5.
+5, -6. Those all have to be excluded. Good. Before we cancel, we have to figure out what the excluded values are. Then we'll cancel anything that we can. And so we end up with x plus 4 divided by the product of x plus 6 and x plus 5. And it doesn't even tell you have to expand it out. So you can even just leave it like that if you want. Okay?
Do they have to all have parentheses around it?
The ones on the bottom would. The one on the top wouldn't have to, because it's by itself.
Will it ask for the excluded values?
No, it won't. These questions are the same exact format. There is one question on here that does, but it's not this one.
So the one in the yellow would be the answer.
Yep, that would be your answer. How would you check it? Plug in a value. Well, pick a random value of x. You wouldn't want to pick any zeros of the bottom, though, would you?
No.
Right? Yeah.
So you cross out whatever is combined, the same,
Yes.
in order.
Yeah, cancel like factors. Right. Okay. Find the difference. All right, so subtracting. This is a little bit harder, right? I think. Remember what we have to do here. Whenever we add up or subtract fractions, we have to get a common denominator, and then we just add or subtract the numerators, right? So first thing we got to do is figure out what is our common denominator going to be. Well, let's factor both of these.
X squared.
And it's gonna be, well, not quite just x squared. I get 8 over x minus 9 over, what does that factor into? The denominator of the second fraction.
Isn't it x and then x plus 1?
Good, okay. So then if I'm gonna get a common denominator, you don't even really have to be real fancy about this. Just think, I've gotta make the bottoms look the same, right? So what could I do? This one right here is gonna be fine, but I could multiply the top and bottom of the first fraction by something to make the bottoms look, make the denominators the same. In other words, common, right? X, well, x plus 1, right? I could multiply by the factor x plus 1. And whatever I do to the bottom, I have to do to the top, right? Now, does everybody agree at this point, we've got that denominator and that denominator are the same, right? That's our common denominator. So we end up with, if we simplify this first fraction, I just get 8x plus 8, if I distribute the 8, right? Times x plus 1, minus the other one is just 9 over my common denominator, right? And I don't subtract the denominators, they're common, right? I leave the denominator, the common denominator stays there. So my final answer just looks like my common denominator of x times x plus 1, and on the top, I have to just subtract the numerators. So what is 8x plus 8 minus 9?
8x minus 1.
There's my answer. Okay? Not that bad, right?
Are you done?
Yeah, I think we're gonna have to be done there.
Ay, ay, ay.
Yeah.
No, thank you.
Okay, we'll get to that one tomorrow. I'm not gonna be here tomorrow, we'll do that one. So here's the plan for the rest of the year then. So I'll open it up if you want to, but you only get 2 attempts. If you wanna hold off on those till next week, we'll finish the review on Friday. Tomorrow you get a work day, I've got the practice final up. If I were you, I would go through the practice final once a week, right? Okay? Then, when you're done, you're done. I'm gonna try to update grades today, and then I'll just try to keep updating grades, and I'm gonna put the final into your grades, so you can just see, you know, when you get to your final grade that you like, you can just stop. Does that make sense? You like that?
Wait, what? I'm confused.
So what I'm saying is, when I update grades, I'm gonna put a slot in there for the final, right? And so, it's gonna look bad at first until you take your final, but as I update grades then, you'll be able to say, oh, okay, there's I like that updated grade, you can just stop. Right? Does that make sense? Okay.